Good evening, everybody. It's 10:33 on a Sunday night, and you know, I'm still not over whatever this is, but this helps. Anyway, what we're going to do is we're going to talk a little bit about a specific problem that I put on the notes that you can see on Schoology, so it will help you in understanding the first fundamental rule of calculus. So we have a function here. It's fun. It's the sine function. We've seen this one before. We've done it when we talked about other questions. When we talked about areas under the curve. Now we're going to say, well, let's find the area under the curve, except for we're only going to find this shaded region right here. So automatically you're thinking, this is evil. I know. Hannah's probably thinking that right now. Sorry, Hannah, but you probably are, and you'd be justified. But it's not that difficult. We'll go through the process step by step. Now, the first thing that we know is that if I went ahead and I said, okay, I'm going to take the antiderivative here. I know that my interval is from 0 to pi. Because I go up to pi over 2, I go down to pi. So this is from 0 to pi. Okay, so we're going to be looking at the area under the curve of sine between 0 to pi. So if I take the antiderivative of sine, well, the derivative of sine is cosine, so the antiderivative will be negative cosine. So we're looking at the negative cosine of x from 0 to pi. Okay, we plug those values in. We can say, okay, well, negative cosine of pi minus, and then we have negative cosine of 0. So cosine at pi is a negative 1 because it's 1 at 0, 0 at negative, or 0 at pi over 2, and then negative 1. So negative 1 is here, negative 1 gives you a positive 1. Minus, at 0, it's a positive 1, so positive 1, negative 1, so negative gives you once again a positive 1, which gives you a 2. So the whole thing here is 2. Yay, we're done, except for the fact that I've got to take stuff out. So from this 2, I'm going to take out this piece and this piece, which should be the same and will be the same, and then this rectangle here. So let's take a look at the rectangle. Let's take a look at the rectangle. The rectangle is nothing really spectacular. This is the exact kind of problem that we did when we talked about the area under the curve. If we're trying to optimize the size of the rectangle, this is exactly that question, where we had x and then sine x, and we're trying to optimize the size of the area of the quadrilateral underneath the sine curve. So the difference is here is we're not trying to optimize. We're just saying we're given specific parameters. That we have pi over 6 to 5 pi over 6. So this total distance is 4 pi over 6, or just 2 pi over 3. And then the height is going to be sine of 5 pi over 6, or sine of pi over 6, which are going to be the same value, which is just going to be a half. So we end up with the area here is 2 pi over 3 times a half. So that's the area of this quadrilateral. The last thing I have to do is find out what this little section is, because this section is going to be identical. So it's going to be, I could rewrite it, I could do the two of them together, but I can also go from 0 to pi over 6, I can say 2 times sine x dx. And I forgot my dx up here, forgive me. I might as well put that back in there. So I can do 2 times the integral of 0 to pi over 6 of sine x dx. So do the same idea. 2 times, and we end up with negative cosine x from 0 to pi over 6. And lo and behold, you end up with a cute little problem that is 2 negative cosine of pi over 6 minus negative cosine of 0. Cosine of pi over 6, I believe, is the square root of 3 over 2. So negative square root of 3 over 2. And then this is 1, this is negative 1, so this is a positive 1. So this ends up with 2 times negative root 3 over 2 plus 1. So lo and behold, the whole thing is 2, but then from it I have to take away 2 of these square root of 3 over 2 plus 1s. And I also have to take away this 2 pi over 3 times a half. And when you do that, you're going to end up with a number that's bigger than 1. But that's really all that we're going to do for finding this cute little peppermint thing. I know that Halloween is tomorrow, and this is more of a Christmassy looking peppermint candy stick, and probably it should have been, I don't know, brown and orange for Reese's Peanut Butter Cup, but I don't have brown and orange pens. Those are weird. So anyway, I hope these are helpful. I hope the notes are helpful. Good luck tomorrow. Have fun with the fundamental theorem of calculus. You're going to find out that we've been doing the fundamental theorem of calculus right along. So my absence at class today is not that egregious of a thing. So, but that's all. Have a wonderful day, and we'll see you guys on Tuesday. Bye-bye.